So the work is the force of friction times the distance. The force of friction is going to be mu times the normal force, also times the distance. And mu they give me. The normal force is going to be the mass times the acceleration of gravity. So mu mg times the distance is going to be how much energy this thing had. Well, that's going to be how much kinetic energy it used to have before it went slamming in. So kinetic energy is going to be 1/2 mv squared. So I could try to cancel out some things, but I'm just going to throw this in. So I've got 0.251 is my mu. My mass is 94.4 grams, so that's 0.0944 kilograms. Gravity is 9.8. And the distance this block slides is 9.15 meters. And that is going to be how much kinetic energy was lost as this bullet slid and block slid to a stop. So once I figure that out, then I'm going to have my Ke that it had right after the collision. Well, my kinetic energy, this number right here, whatever I get for all of this, is going to be my kinetic energy before it started to slide. So that is going to be 1/2 the mass times the velocity squared. This is the speed after the collision. So when you take your kinetic energy, double it, divide by your mass, so there's where the mass would cancel out if you were smart. I could wind up, I'm sorry, not to say you're not smart, you are all smart. V squared, so my velocity is going to be the square root of whatever this works out to be, 2 Ke divided by the mass. So now I know the speed of the block and bullet after the collision. Okay, so this one is going to give me the speed of the block and the bullet after the collision. So that brings me to what is the speed of the bullet. Now I've got my conservation of momentum problem. So now I know that the mass of the bullet times the velocity of the bullet must equal the mass of the bullet plus the mass of the block times the velocity of the block. And this V is this V that I just solved for here. So that's going to go in here. This is the mass of the bullet plus the block. This is the mass of the bullet. This is what you're solving for, so you can solve for your velocity beforehand equals.